Welcome everyone. This is the first meeting of the Research Triangle High Rehabilitation Clinic. I'm Dylan Burns, and I'd like both of you to introduce yourself.
I'm Ankish, and I'm an addict.
I'm Evan, and I'm a turtle who likes to drink milk.
As part of the rehab program, I'm going to teach all of you your limits in calculus. I changed clothes. Where's my marker? Thanks. Before we learn about limits, we first need to learn about the average and instantaneous rate of change. We have a function x squared here. If you want to take the average rate of change, or the average change in the slope, from the points x equals 3 to x equals 4, you use the formula delta y, which is change in y, over delta x, which is change in x, and you get the value 7. For the instantaneous rate of change, it's the same thing, but you're more closely zoning in on a specific point. So we chose to take the instantaneous rate of change at 3. We chose a very close value to 3, 3.01, and we plugged those values into the same formula, and we got the answer of about 6. Graph at 2 points. The slope of a tangent line is the average rate of change over that interval. I changed clothes again. There are 3 main ways of evaluating limits. The first is graphically. You have the graph of a function and you're trying to find the limit as x approaches 2, but the value doesn't exist. So if you look at the graph as it approaches 2 from the bottom and the top, you can see that it approaches y equals 2, which is the answer. For numerically, you have the limit as x approaches 1 of the square root of x minus 1 over x minus 1. And if you plug in values that are slightly below and slightly above x equals 1, you get that the limit of x approaches 1 is equal to 1/2. For algebraically, you have the limit as x approaches 3 of the function x squared minus 4x plus 3 over x squared plus x minus 12. If you factor out the numerator and the denominator and you cancel the values, you get that the limit is equal to x minus 1 over x plus 4, and the answer is equal to 2/7.
Limit laws. Now first up, we have the constant limit law. The constant limit law says that if you have a limit going to a constant, then it's just equal to the constant. Here we have the addition limit law, which says that if you have 2 functions being added together inside of a limit, they can be separated into 2 different limits being added together. That's the same with the subtraction limit law and the multiplication limit law, which just means that if they're subtracting or multiplying within the limits. Here we have the division limit law, and if there are 2 functions within a limit that are being divided, you can just make it the limit of the numerator divided by the limit of the denominator. Here we have the power limit law. That means that if the inner function of the limit is being raised to any exponent, the entire limit can be raised to that same exponent. Finally, we have the composition limit law. That means if you have a function inside of another function in the limit, you can just do the limit of the inner function and with the outer function on top, which makes it a lot easier.
Here are 3 more topics and limits that you guys should know. First is limits and limits and continuity. There are 3 main types of discontinuous functions. The first is a hole, where one value is missing. The second is a jump discontinuity, where the function jumps up or down at a value. And the third is an infinite discontinuity, where the function goes infinitely up or infinitely down at a value. For trigonometric limits, here are 2 types of trigonometric limits that you guys should memorize. The first is where the limit is approaching 0 and the function is sine of x over x. You should know that that equals 1. The second is where the limit is also approaching 0 and at the function 1 minus cosine of x over x, and that one it equals to 0. And finally, for the intermediate value theorem, it states that a continuous function can't skip values. That's pretty obvious. You can see in this graph, there's point A, point B, and point C exists in between them. And the corollary states that if A and B have opposite signs, there must be at least 1 0 on the interval. So here you can see A is positive, B is negative, and there's 1 0 on the interval. I'm very proud of you guys. After only 1 session, it seems like both of you have conquered your limits.
Not me. I'm addicted to milk.